Assalamualaikum to Dr. Zafira. We are from Haccp team number 9. We'll be presenting about our Haccp plan. This is the table of content of our company profile. We will be talking about us, and then our mission and vision, and then our philosophy and about the company.
First, I will introduce our company, Mr. Lego. Mr. Lego is a manufacturing industry that produces keropok Lego. We start our first store at Kampong Lau. Until today, Mr. Lego has 5 branches at different cities in Malaysia. Our company vision is to establish Mr. Lego as the most well-known brand in the keropok Lego industry. The mission of our company is to sell the best quality keropok Lego to our customer. To achieve this mission, all the keropok Lego are made from fresh ingredients and processed under proper food safety legislation.
Our philosophy sounds like you are what you eat. The philosophy refers to the idea that food controls a person's health. So it is a straightforward philosophy as Mr. Lego prioritizes consumer safety and health when making keropok Lego. So creating a high quality and safety assurance keropok Lego in the world is our main objective. So by providing high quality keropok Lego, we can ensure that consumers' health is not at risk. So this is the details of our company. Our company name is Mr. Lego Sendirian Berhad, and our company number is 123456U. And we also have stated our office address, telephone number, fax, email, and website. Date of incorporation 2001. Our authorized capital and paid up capital. Principal bankers Hong Leong Bank Berhad, Maybank Berhad, and OCBC Bank Malaysia Berhad, and company secretary. Now we'll be moving on to Haccp team. So this is our Haccp team. Me, myself, Faizan Nufitra binti Hasim, I'm the operation manager, and Ong Shipe as the production manager, and then Nushaira binti Abu Bakar as packaging manager, Wu Yichin as quality manager, and last but not least, Khairul Nisa Nabila as engineering supervisor.
Mr. Lego is a food factory that produces high quality of keropok Lego. Food factory Mr. Lego is the earliest factory in the application of the Haccp system. The Haccp plan defines the process of validation of control measure or a combination of control measure fully supporting the food safety management system. All the process of making keropok Lego will be close controlled and monitored periodically by the Haccp team leader to ensure the quality of food is at the good level. This monitoring will be taken from the receipt of the raw material until the product is received by the customer. Food safety hazard including in the Mr. Lego Haccp program is biological, chemical, and physical. Therefore, in this program, we will identify food hazard that may be present in the food process so that we can take appropriate action to prevent the existence of the food hazard in the product.
Mr. Lego acknowledged that food safety is essential to our business and it values important and necessities. We pledge to constantly produce high quality, hygienic, and safe products for our customer, create a healthy workplace, as well as maintain and improve an efficient food safety system based on Haccp principles. Keropok Lego is one of the traditional foods in Malaysia. The word Lego is derived from the Terengganu Malay accent, which has the meaning of roll. Fish stick, fish sausage, and fish fritters are other names for keropok Lego. It is a favorite snack for most Malaysians and it has been a common dish for those who live in Terengganu coastal region. Keropok Lego is deeply linked to fishing community to the point that they eat it almost daily as snack or side dish at every meal. It was widely accepted since it was convenient and could be had at any time, such as at breakfast, lunch, tea time, dinner, and supper.
Process flow diagram starts with receiving all the ingredients including raw fish, sago or starch flour, salt, sugar, MSG and the packaging material. And after receiving all the ingredients, the next process is storing. So there will be 3 types of storage: frozen storage, dry storage and packaging storage. The frozen storage temperature should be less than -18 degrees Celsius. And then the fish will be undergoing washing, cleaning, and grinding processes. Cleaning process includes the removal of bones. And after that, the grounded fish will be weighed and packed and will go to the process of freezing in the frozen storage. And after that, the next day, they will undergo crushing process and then the dough making process. In the dough making process, all the other ingredients like sago or starch flour, salt, sugar and MSG are added together and mixed, and then the dough will be weighed and shaped and rolled so that all the size of the dough will be the same. And then they will undergo the process of boiling, where the temperature should be 120 degrees Celsius and the time should be 15 minutes. And then after that, they will be drained and cooled. And the next process is baking, which should be done in less than 2 hours. And then storing, which the temperature should be around 0 to 3 degrees Celsius. And then shipping process, also the temperature should be 0 to 3 degrees Celsius.
Next, in determining principle number 2, this need to be done to eliminate the possible food safety hazard. These are the CCP decision tree to identify which process required critical control point. After we take all in consideration, we summarize that receiving, storing, dough making process, boiling, cooling, and shipping required CCP. We categorize each CCP according to its type of hazard. The first CCP is during the receiving of raw fish. The potential hazard are coliform and Escherichia coli. The prevention that can be done is to check the temperature of fish to be below than -18 degrees Celsius. Next CCP is during storing raw fish, which need to be stored below than -4 Celsius to prevent the significant hazard. Next CCP is during the boiling process, which need to be boiled completely at 63 Celsius. For CCP number 5, for cooling the cooked product, it need to be cooled to 21 Celsius or lower. For prevention coliform and Escherichia coli to surface, the frozen food need to be kept at -18 degrees C or lower. For the third principle in determining the critical limit, which are important to remove or reduce the hazard to a safe level. During cooking, the FDA guidelines stated that raw fish need to be cooked for at least 15 seconds at 63 degrees Celsius and need to be cooled to 21 Celsius or lower for 2 hours and continue for 4 hours at 5 Celsius. For storing the cooked product, fresh food should be packed in ice and stored at -1 Celsius to 2 Celsius in the refrigerator. And for the dough making, Codex standards stated that maximum use of food additive is only 300 mg per kg. Principle number 4, which is monitoring system, is to ensure the critical limit are continuously achieved. The monitoring system that we done is on the CCP number 1, which to control the coliform and Escherichia coli. How can we do it is by using the thermometer to check food temperature during receiving, and this need to be done for every receiving and can be done by receiving employee. Next is the monitoring system for storing raw fish, which is CCP number 2. This need to be done to avoid any coliform and Escherichia coli. How to be done is by monitoring and take the refrigerator temperature reading, and the refrigerator need to be cleaned every 2 weeks. Next, for the CCP number 4, which is boiling process, the monitoring procedure need to be done is to use the temperature gauge to take the boiler temperature, and the boiler need to be at 63 degrees Celsius to avoid any coliform or Escherichia coli, and this frequency need to be done for every batch during the cooking process. For the CCP number 5, which is for cooling process, the QC staff need to monitor the freezer temperature indicator. This don't have to do continuously, it just need to be done for every 2 hours, and the refrigerator and the freezer need to be cool to 21 degrees C or lower in 4 hours.
The fifth principle of the Haccp is the corrective action. To determine the corrective action for each CCP, we need to determine all the deviation that will be occurred during the process, the corrective action that will be taken, the person in charge, the date, and also the batch number of the products. So first, for the receiving process, the deviation that will be occurred is that the temperature of the raw fish is not maintained below negative 18 degrees Celsius, and also we may receive the tar or the foreign materials. So the corrective action that will be taken is that we can rework or hold on. We can notify the suppliers and the supervisors for all the deviation. We can reject the fish whose temperature exceeds negative 18 degrees Celsius, or maybe we can reject the tar materials. We can also do the inspection about the products before we receive, and we can find another suppliers after the inspection. So the corrective action that will be taken during every receiving of the products, for every batch of the products by the receiving employee. So second is the storing process. The temperature of the raw fish may not keep between negative 1 degree Celsius to 2 degrees Celsius, and the arrangement of the stock will be compact and will mix with other food products or the chemicals. So the corrective action is that we can rework or hold on. We can notify the supervisors for all the deviation. We can adjust the temperature of the storage so that it can maintain between negative 1 degree Celsius to 2 degrees Celsius. We can throw the product if the temperature is not maintained at the range of negative 1 degree Celsius to 2 degrees Celsius. We can arrange the stock with the suitable gaps or using the racks if needed. We can remove the extra amount of the stock according to the capacity of the store. We can remove other food product or the chemicals, and we can also check the product contamination regularly. So the corrective action is taken by the production employee every day and for every batch of the product. Next, the deviation that will be occurred during the dough making process is the excessive use of the MSG, which will exceed 300 mg per kilogram. So the corrective action that we can take is that we can rework on it. We can notify the supervisor for all the deviation. We can do inspection on the food additive used before we receive it. We can test for all the contaminants in the food additive. We can reject all the unqualified food additive and search for the other suppliers. So this corrective action will be taken by the production employee during every dough making process or before the dough making process for every batch of the product. Next is the boiling process. The deviation that will be occurred during the boiling process is the temperature of the boiling do not reach 63 degrees Celsius. The time of the boiling do not reach 15 seconds. So the corrective action is we can rework on it. We can notify the supervisor for all the deviation. We can reprocess the uncooked product. We can throw the overcooked products. So this action is also taken by productive employee before the boiling or during the boiling process for every batch of the product. The deviation that will be occurred during the cooling process is the temperature of cooling does not maintain below 21 degrees Celsius. The time of cooling does not reach 4 hours. So the corrective action we can take is that we can rework on it. We can notify the supervisors for all the deviation. We can adjust the temperature until 21 degrees Celsius or lower. We can throw away the spoiled products, and we can extend the time of cooling until 4 hours. So this corrective action for the cooling process is done by production employee before the cooling process and during the cooling process for each batch of the products. Last is the shipping process. So the deviation that will be occur during the shipping process is that the temperature of the frozen products do not maintain at negative 18 degrees Celsius and lower. So we can rework on it or hold on. We can notify the supervisor for all the deviation. We can adjust the temperature until negative 18 degrees Celsius or lower, and we can throw away the spoiled products. So this corrective action during shipping process is taken by quality control supervisor during the shipping process for every batch of the product. The principle 6 of Haccp is the verification procedures. For the determination of verification procedures, we need to determine what to verify, the method to monitor, the date, and also the person in charge. So first, for the verification of the critical control point, which is the calibration of the temperature. So the method to monitor is we can review the calibration record once in a month by quality control supervisor. Next is the verification of the Haccp system, which means that we need to verify all the Haccp preliminary steps, the prerequisite programs, and the Haccp analysis. So we can review the Haccp system record during the initial implementation of this Haccp plan by the Haccp team. Third is the validation, which refers to the re-examining the Haccp analysis, the critical control points, the critical limits, and also the monitoring activities. So the method to monitor is we can review the scientific and the technical record. We can take the consultation from the external or the third party, and also we can do internal or in-plant observation or experiment once in a month by quality control supervisor. The last principle of Haccp is the list of documents and records. The list of documentation includes the company profile, organization chart, Haccp team and profile, Haccp scope, food safety policy, food safety objective, product description and intended use, product description and technology, process flow diagram, the 7 documents of Haccp principle, Haccp plan summary, and also SSOP procedure. This is the example of the record documents, which includes the title of record, the product ID, name of the staff making entry, name of reviewer, and we will also record the date, the signature of staff making entry, the reviewer signature, and also the additional record.
CCP number 1 is the receiving of the raw material. Potential hazard is coliform and Escherichia coli. Critical limit, fish temperature should be at or below negative 18 degrees Celsius. Monitoring the fish temperature, use thermometer to check the food temperature during the receiving. Frequently, every receiving. Who's check the temperature is the receiving employee. So deviation, the temperature of the raw fish is not maintained below negative 18 degree and received through or foreign material. Preventing measures is examination of supplier certificate upon the receiving supplies audit. Temperature check must less than or equal to negative 18 degree. So the correction action is can rework and hold, notify the supplier and the supervisor for all the deviation, reject fish whose temperature exceed negative 18 degree and chew material. Do inspection about the product before the receipt and find another supplier after the inspection. CCP number 2 is storing raw fish. The potential hazard is coliform and Escherichia coli. The critical limit is -1 to -2 in the refrigerator. We need to monitoring the fish temperature by taking the refrigerator temperature reading and clean the refrigerator. We do it daily and or every 2 weeks and done by production manager. Deviation is the raw fish does not keep the temperature between -1 to -2 degree and compact arrangement of stocking product and mixing the other product and the chemical. The preventive measures is examination of the supplier certificate and keep food -4 degrees Celsius or a cooler. Correction action is notify the supervisor for all the deviation and adjust temperature of the storage to maintain at below -4 degrees Celsius and throw the product if the temperature is not maintained, and arrange the stock with a suitable gap and remove extra amount of stock. CP number 3 is the dough making. Potential hazard is food additive. Critical limit is only 300 mg per kilogram that allowed to use. We monitoring with controlling the additive, the amount of additive during the every batch during the nettling. Deviation is excessive use of food additive. Preventive measure is use a standard allowable amount of additive. Correction action is inspect the food additive used before receipt and test of all the contaminant in the food additive and reject all the unqualified food additive and search for others. CCP number 4 is a boiling. Potential hazard is coliform and Escherichia coli. The critical limit is a cook for 15 seconds at a temperature of the 63 degrees Celsius. We monitoring the temperature of the boiling water during the cooking for every batch, and the deviation is the temperature of the boiling do not reach 63 degrees Celsius and the time of boiling did not reach 50 seconds. This measure is the boiling completely until 63 degrees Celsius temperature, and correction action is the reprocess the uncooked product and throw the overcooked product. CCP number 5 is a cooling process. Potential hazard is coliform, Escherichia coli, Vibrio cholerae, Vibrio yeasts. The critical limit is a cool to 21 degrees Celsius or lower in the 4 hours. We monitoring the fish temperature non-continuously for every 2 hours. Deviation is temperature of cooling does not maintain below 21 degree or lower and time of cooling did not reach 4 hours. Correction action, adjust the temperature until 21 degree or lower, throw the spoiled product and extend the time of cooling until 4 hours. CCP number 6 is shipping. The potential hazard is coliform and Escherichia coli. The critical limit is frozen food must be kept at -18 degree or lower. We monitoring the freezing temperature for every shipping. Deviation is the temperature of the frozen food do not maintain at -18 degree or below. The preventive measure is food frozen must be kept at the -18 or lower to maintain its quality. The correction action is adjust the temperature until -18 or lower and throw the spoiled product. Conclusion, the food company can use Haccp and food safety plan as the practices to reduce the risk of contaminated food. Every food and every process system used by a food business require a specific food safety strategy. It is not a set of numerical requirements that a company must follow, rather it is a planned, executing and verifying approach. These numerical criteria are established by each food company based on scientific knowledge.